Welcome to True Projects. In this video, we are going to explain about the project that is application of blockchain technology in carbon trading market, a systematic review. So before getting into the execution, first let us understand what is this project about. With technology advancing rapidly and the widespread use of computers, smartphones and other electronic devices, the amount of carbon being emitted into atmosphere has increased significantly. This rise in carbon emissions contributes to global warming, which in turn can trigger extreme weather events and natural disasters such as floods, earthquakes, and tsunamis. Human activities, including transportation, industrial production, and even daily electricity usage, play a major role in this problem. As the world continues to rely heavily on technology, it becomes more important than ever to implement measures that can control and reduce carbon output, protecting the environment, and ensuring a sustainable future for the planet. So, to tackle this issue, that is this challenge, the United Nations introduced the Kyoto Protocol in 1997, creating a system to regulate carbon emissions through a market based approach. Under this system, each household or organization is allocated a specific carbon emission limit. If a household exceeds this limit, it must pay a tax, while any unused carbon units can be carried forward or saved for future use. This system it encourages individuals and organizations to monitor and also reduce their carbon consumption, offering financial incentives for responsible behavior. By linking environmental responsibility with tangible benefits, the Kyoto Protocol aims to promote sustainable energy practices and reduce the overall carbon footprint globally. Right now, the system that manages carbon emissions and taxes rely on single centralized server. This means that all the data is stored in one place, which makes it vulnerable to mistakes or even tampering. If someone want to, they could potentially change the records without being noticed. Because of this, the system isn't very transparent and people can't always trust that the data is accurate. These problems show that we really need a better solution on that it is secure, transparent and reliable. A system like this would make sure that carbon emissions are tackled correctly, taxes are calculated fairly, and everyone can trust the records without worrying about errors or the manipulation. So to overcome with all such issues, this project it introduces blockchain technology. So this project it proposes to use blockchain technology to make the management of carbon emissions much more secure and reliable. Unlike the current system, where all the data is stored at one central server and can be tampered with or contain errors, a blockchain based system spreads the data across many places. This means that once a record of carbon usage or tax payment is added, it cannot be changed or deleted without everyone noticing. By decentralizing the records, the system makes all carbon consumption and tax information transparent, verifiable, and tamper proof. Everyone can trust the data because it is permanent and securely stored, which ensures a fair and accountable way to manage carbon emissions. And here, the system uses smart contracts to automatically record carbon usage and calculate taxes, which means it doesn't need any third party to verify the information. Every time a record is added, it is stored as a block with a unique digital fingerprint called hash. This makes it easy to detect if anyone tries to change the information, ensuring that all records are accurate and trustworthy. In other words, the system keeps everything secure and transparent so both the users and authorities can rely on the data without worrying about errors or manipulation. Overall, the system solves the main problem in carbon trading and taxation, like lack of transparency and trust. Because all records are secure and tamper proof, people can be confident that the data are accurate. At the same time, it encourages everyone to stick to their carbon limits and make smarter choices, which helps to reduce their carbon footprint and promotes a more sustainable way of living. And in this project, we are using Ganache, which is a local Ethereum blockchain to deploy. We have many Ethereums, that is, we have many blockchains, and for this project, we are using Ethereum blockchain. So Ganache acts as a tool for for localizing, for seeing all the Ethereum transactions to deploy and test our smart contracts for managing carbon emissions. It gives accounts to both the carbon department and customers, and it keeps track of everything. We can see all the Ethereum transactions here, like logging carbon usage, calculating taxes, and verifying payments. Ganesh also lets us to see the details of each transaction, the information in each block and the gas used, which helps to ensure that the system runs securely and transparently. And here in this project, we are also using MetaMask as a browser-based Ethereum wallet to interact with the smart contracts we deployed. It allows both the carbon department and customers to securely record carbon usage and check tax payments. MetaMask it allows to show the ETH usage and gas fees for each transaction, which helps to maintain the transparency and build the trust in the system. To further enhance the transparency, that is, to further enhance the efficiency and sustainability of the carbon emission management, the system introduces two key extensions. The first one is data compression for blockchain storage. The system stores all carbon consumption and tax related data on the blockchain. To reduce storage cost and minimize associated carbon emissions, a data compression algorithm is employed. This algorithm compresses all the data before storing it on the blockchain, reduces data size while maintaining integrity. So, by optimizing storage, the system lowers the energy usage, indirectly contributing to reduction in carbon emissions. Then comes AI based consumption analysis. So, here, second, an AI based consumption analysis is included to help users understand their carbon usage. The AI looks at each user's consumption patterns and classifies them as high, medium, or low. This gives users clear insights so they can take action to reduce their usage and save on tax, promoting smarter energy, that is, smarter energy use and a small carbon footprint. Moving on. So, here we have five modules. That is carbon department login. So the carbon department can securely log into the system using username and the password as an admin, giving them access to manage all the operations. And the carbon department, they can add customers. That is, the admin will be able to add new customers to the blockchain who are participating in the carbon emission management system. Then we have smart contract carbon taxation. So every month the admin records each customer's carbon consumption. If consumption is below the limit, no tax is charged. If it exceeds the limit, tax are applied based on the current usage and any previously saved units. All of these details are securely recorded on the blockchain. Then view and emission. So the admin can view all the customer consumption and tax records up to the present date, ensuring transparency and easy monitoring. Then we have customer carbon consumption check. Customers will be able to check their own carbon consumption by entering their ID, allowing them to see how much they need to pay in taxes and monitor their usage. To execute this project, we need different requirements. So coming to hardware, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and ROM of 25 GB and above. Software requirements are Python ideally of 3.7.0 version, Node.js Visual Studio Community version, Ganache and MetaMask as Chrome extension. Coming to backend languages, Python, JavaScript and Solidity. Framework is Flask. Frontend languages are HTML, CSS, JavaScript and Bootstrap 4. So this is the overview of the project. Now let's execute. To execute, open the code folder that contains source code files. So let's open the code folder. These are the source code files of this project. Let's understand each of them. So this is the build folder in which we have JSON files. This is the contracts folder and here we have migrations. And this is the model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And this is the static folder in which we have CSS, JavaScript and Bootstrap files which are important for the visual appeal. And here we have templates folder. In this we have HTML pages used in this project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. So this file, it contains information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have one JSON file, SQL file, that is Solidity file. And this is the Windows batch file. So instead of executing this project through command line interface, we have created this Windows batch file. And this is the configuration file. Now let's execute. So for that, first we need to open the, that is we need to run the blockchain server. So let's host the blockchain server. For that, open the Ganache. It's opening, just wait for a while. So select the workspace. Here you can observe server has been hosted. Now minimize it. And here you can see we have balance of 99.9 ETH. So let's minimize it. And let's start running. So click on this one, double click on this run.bat file. Here you can see Python app file has been compiled. App file has been compiled. Now this command, that is Python space app.py, it will check for the syntax errors. That means it will execute the Python script and check for syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port, unless configured differently. So the application has been hosted. Just wait for a while. So this is the address where application has been hosted. So copy this local link provided by the Flask framework and paste it in any web browser. I'm copying it. I prefer Chrome, so I will paste it in that. Paste the link here and now click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So let's start executing. So first we need to log in as Carbon department. So click on that link and give username and the password. Now click on login. So Carbon department has successfully logged in. So here we can see two links, that is add new customer and smart contract taxation. So here we can see links on up also. So here you can see add new customer, smart contract, customer taxation view, tax and emission and storage cost graph logout. So first we are supposed to add the customer details. So click on add new customer. So here on the screen, you can see all the details, right? So we need to give all these details to add a customer. So let's give the customer name as John and give carbon limit. So let's randomly give carbon limit of 100 and let's give contact number. So I'm giving contact number randomly and give his mail ID. So let's give his mail ID as jhon@gmail.com and give his address. And now click on submit. So before clicking on submit, let's see how many blocks we have in blockchain. So click on blocks. And here, initially we have only 4 blocks. Now let's click on submit and see how many blocks will be added. So click on submit. So here you can see customer has been added with his ID along with the customer ID and customer name. And here if you click on show transaction receipt, we will be able to see it. So click on show transaction receipt. And here you can see transaction receipt. So these are all the details. So here we can view entire blockchain log after the record storage. So this log contains the details like block number, timestamp, hash code, and many other details. Similarly, we can add many other customers also. So let's open Ganache and see how many how many blocks are added. So here you can see block number 5 has been added in which John details are stored. So let's click on this. And here you can see block number 5. Here we have gas used, gas limit, mined on, and block hash. This is the block hash. And here we have transaction hash. So this is the transaction hash. Now minimize it. And let's create a new customer. So let's add new customer. Click on hide transaction receipt. And let's add the another user where the user would be Paul. And give the carbon limit as 100 here also, and contact number, some random number I'm giving, and give the mail ID and give his address. And click on submit. So here you can see customer 2 has also been added. And here if you click on show transaction receipt, you can see all the details. So here this is the block number 6. And if we open Ganache, you can see block number 6 has been added. And here this is the block hash. This is the block hash. And here also you can see block hash. If you click on it, this is the block hash. So accordingly, you have completely blockchain related information of this customer ID block related details. So hide it. Now let's click on smart contract and carbon taxation. So click on it. Now we will be able to generate consumption and taxation bill for any customer that we want. So let's select customer. So let's select customer John and here total consumption. So let's give 80 as total consumption. So total 80 units of carbon he has been consumed. So the bill date would be 10th of October. Now click on submit. So here you can see current tax pay amount is 0 for bill date of 2010. As we have given carbon limit was 100, that is why here it is showing 0 because it is less than the limit. So he is not needed to pay the tax. He is not allowed to pay the tax. And if we click on show transaction limit, that is show transaction receipt, he can see all the block related details where all the details are stored. Now click on hide transaction. Let's generate bill for the other customer, that is Paul. So click on this and select the customer ID, that is Paul. And let's give 200 units of carbon he's using. Now let's give the bill date, that is October 10th, where he has to be paid. And now click on submit. So here you can see total tax amount to be paid is 100 rupees as of this date. And if you click on show transaction receipt, you can see this is the attribute dictionary. And here we have block number 8. So these details are stored in the block number 8. And here we have block hash. So hide transaction receipt. So here you can see tax has been calculated for the user, that is for the customer Paul, and for John, tax was not calculated because he was using less than the limit. Now let's click on view tax and emission. So click on it. So here you can see customer ID, bill date when it was generated, and month limit. I mean, bill date is when he has to pay. And here we have monthly limit. So monthly limit is 100 units of carbon. And the John has used 80 units and the Paul has used that as a customer ID too. He has used 200 units. And here balance carbon limit. So he has 20 units of carbon that he can use it for next month. And here he has used extra 100 units. So that is why tax has been calculated. So like this, you can see how to calculate the tax of the customers who is using carbon. Now let's click on storage cost graph. So click on that. Here we have plain and compressed storage cost graph. Here in this graph on x-axis we have technique name and on y-axis we have storage cost. If you observe without compressing the storage, it is taking high cost than the compressed storage. So here you can see plain storage is taking the more cost than the compressed storage, which is an extension. Now let's click on view tax and emission. So click on that. So here you can see all these details. Now click on log out. And let's log in as customer carbon consumption login. So click on that. So here we need to provide the ID. So let's give the ID of John, that is 1. And now click on submit. So here you can see customer carbon consumption data. So user John, he will be able to see all his data. So here you can see customer ID 1, bill date, monthly limit, consumption carbon is using 80 units of carbon and balance amount is 20 and taxable amount is 0. So here you can see AI suggestion that it is high emission. It is emitting high. Now let's check with the other one. So let's check with John, which is 2. Click on submit. So here you can see customer ID 2 and bill date is, this is the bill date, monthly limit, consumption carbon, and here you can see carbon, that is balance carbon limit and taxable amount. And you can see AI suggestion, that is AI suggestion, that is high emission. Now let's emit less amount of carbon and see how much, let's see how much will be generated. So click on carbon department login and let's give username. Click on login. So click on smart contract taxation. Now let's give the customer for Paul. Let's generate bill for Paul. Let's generate 20 units of carbon consumption and bill date would be for the November month, that is November 1st. Click on submit. So here you can see there is 0 bill date, 0 amount to pay. Now log out and let's click on customer carbon consumption. So click on that. give the user to click on submit. So here you can see customer ID is 2, bill date, monthly limit, 20 carbons has been used, and 80 is the limit. And here you can see medium emission. So based on the consumer, that is based on the carbon used by the consumer, it is predicting it as medium emission of carbon. So here he is using medium amount of carbon. He's emitting medium amount of carbon. Now log out. Click on home. So this project, it provides a secure, transparent and efficient way to manage carbon emissions and taxes by using blockchain. It ensures accurate records that cannot be tampered with, encourages people to stay within their carbon limits and promotes a more sustainable lifestyle for the environments. Let's see how many units have been generated. So here you can see total 9 blocks are created in which data has been stored. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.